So I guess we can start. Hello, hi, ARV. Can you please confirm whether am I audible or not? And my slides are also visible. Thank you so much. Yeah, so let's start. Good evening, all. My name is Jituraj Singh. I am Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. I am currently working as an additional teaching assistant for this particular NPTEL course, which is NOC 25 CE30, Geotechnical Engineering 2, also known as the Foundation Engineering. The course is currently being tutored by Professor Dilip Kumar Pedia, who is Professor in Department of Civil Engineering from IIT Kharagpur. This is the particular program where the this is a collaborative program between NPTEL and the PMRF, where they are assigning some dedicated uh, TAs to deal with to have a live interaction with our learners of NPTEL course. And for this particular course, I have been assigned with a particular task where I'll be dealing with the learners of this particular course who are enrolled in this. So what are the objectives of the session? So those who are attending for the first time, these sessions are particularly meant to interact with the learners. We'll be having discussion on some of the important concepts which is required to solve any assignment problems. We'll be solving some of the sample questions related to that particular week's content. We'll also be solving some of the doubts for that particular session. And apart from that, if you have any other course related query or any other non-technical query related to the career guidance, like please feel free to ask. We can help to whatever extent possible from our end, and kindly try to have as much interaction as possible so that we can bring out the best from this particular interactive process. So let's start with our session today. So today's session is particularly dealing with some of the part of the geophysical investigation along with the lateral earth pressure theories and the calculation of the lateral earth forces which are acting on the soil. And so that's why we'll be dealing with that particular part. And the sample questions are designed to deal with that particular theory. So let's start with our course today. So the first question which is given to you. So uh, if your seismic reflection test is a type of the geophysical investigation test, and in that particular test we need to analyze what type of waves are being currently used to investigate the soil. So among all these four options, you need to analyze the type of the seismic waves typically used in the seismic reflection test is. Okay, let's wait for other learners and let's see if they can give an input. So any answer, guys? Okay. So the type of waves which we are dealing with, like for the investigation of the soil property in the seismic reflection test, is the body wave. So let's have a little demonstration on that. So usually if we see, assuming that this is a particular soil medium, and the let's say you are having a certain source which will basically utilize to transmit the waves in the soil, and then there is another particular or source, or I'll say the receiver. So whenever this particular source is subjected to some external force, due to the intrinsic property of the particles, when this particular source has been struck with some external medium, there are some disturbance of the particles, and due to that disturbance of the particles beneath the soil, there is a generation of a waves, or we can say the particles will vibrate in such a manner such that it will lead to the generation of the waves, and the waves which is basically transmitting from the surface is known as the surface waves, and the waves which is basically getting transmitted from the soil, or let's say the ground underneath, is known as the body waves. So this is your particular source, and this is your receiver. So we are basically utilizing these particular waves which are getting transmitted through the soil, or we are also saying it's getting reflected, because it's not perfectly getting reflected from the soil medium or the another stratification, rather than there is some transmission or the uh, wave refraction in which the certain energy is getting transmitted to the layer underneath, and some of the energy is getting reflected from this particular top layer or the top surface of the soil underneath. So this refraction behavior is taking account of the diffraction of body waves, and we can utilize this particular phenomena for understanding uh, the what is the soil properties available in this part. So the correct answer for this particular question is body waves, and yeah, that's what I want to highlight here. If you have any doubt, please feel free to ask. If not so,
Sir, is it also called as a shear waves
uh,
or the different?
yeah, shear waves are different.
Okay, sir.
So that basically comes, as per my knowledge, it comes for the surface waves, or like, yeah, usually it comes for the surface waves, the shear waves.
Okay, sir.
Yeah. Now let's move to next question. So among these four type of ground available, which type of the medium is having the highest resistivity?
Sir, is the question is soil or bedrock? Is it a material?
It's a material. That's why I mentioned the ground.
Because one of the option you have given rock, but question says it is a soil.
Yeah, so soil that has the highest resistivity from the following option is, mm, yeah,
The
so that's,
material that has highest resistivity or the soil that has highest resistivity.
so take it as a, the answer is bedrock, so definitely, yeah, so it's a material here which you are talking about. Yeah, answer is C, bedrock. So it's having the highest resistivity. Since the distances interparticle distance is very less, and they are very highly dense material available in the case of the bedrock, so yeah, it will offer the highest resistivity among all those four options. So that's why the correct answer is option C, it's bedrock. Any doubt in this, Vijay?
Clear, sir. Okay.
Okay.
This resistive means penetration, some waves penetration, what resistive? Resistivity.
Yeah, so resistivity, like basically for measuring the, let's say, the medium properties, we are basically taking the voltage difference. So that voltage difference will have the particular conductance, and that conductance is very less in the bedrock. So since the conductance is less, so it will be having the highest resistivity. So that's why it's in the bedrock.
Okay.
So basically it's bedrock. Then uh, it's a straightforward question. So usually for calculating the active earth pressure, what type of relation we use to account for the active earth pressure or the pressure coefficient? So you need to select one of the option. Yeah, so correct answer. Yeah, so let's check. It's a straightforward question. So yeah, answer is option B. Is 1 minus sine phi upon 1 plus sine phi. So usually to account for the active earth pressure or the lateral active earth pressure, the coefficient which we'll use is dependent on the internal friction angle, and from the earth pressure theories, it has been taken into account through 1 minus sine phi upon 1 plus sine phi. So let's move to the next part. Yeah, so the internally stabilized soil system from the following option. So which of one is the internally stabilized soil system? So let's check the answer. We have one answer. It's B. Yeah. So the correct answer is reinforced earth threatening pile. So in the question, it has been asked which among all these four options can be accounted as the internally stabilized soil system. So let's say if you are having a, if we take the gravity retaining wall. So gravity retaining wall usually have this particular structure where the soil resistance available, where the overturning happening due to the lateral forces of the soil is registered through the gravity load, or like to the gravitational force. So the whatever overturning moment which is generated due to the soil available at the backfill, this particular moment has been accounted using the gravitational or the body weight of the retaining wall, and that's why the resistance mechanism is happening through some external force which is has been provided through the dead load of the gravity wall. If we see for the reinforced earth retaining wall, so reinforced earth retaining wall usually come with the retaining wall, and then they are having let's say this is your particular ground which has been registered to the retaining wall. This retaining wall is connected through some nailing, and the these nailings basically take into account the overturning of this wall and resist them by providing the necessary shear tractions at the interface of the soil and the nails. These shear tractions basically provided the required shear resistance forces, and which basically helps in resisting the overturning of the wall. So this is the gravity retaining wall. This is reinforced earth retaining nailing. Then next you are having the cantilever wall. So cantilever wall also have the regular geometry, but instead of that this cantilever wall is basically anchored into a soil medium which is having the high density, or it's the required resistance is high, or it's very dense medium, and this particular dense medium will basically try to provide the necessary support to the wall, and this necessary support will make this wall as a cantilever, will provide a cantilever mechanism which will basically helps in resisting the lateral forces coming from the soil at the backfill. So this is the cantilever wall. So among all these three options, if we see like the gravity retaining wall and the cantilever wall are acting as the external forces and external resisting forces, and they are not stabilizing system by through any internal forces. While if we see the, or they are providing the required forces either through their dead weight, or let's say the some fixed support which is not at the part of the soil. But if you see for the reinforced earth retaining nailing, this nailing system are acting, are providing the required tractions, or tractions, or I can also say the shear forces. These shear forces are acting at the interface of the nails and the soil, so both soil and the nail are basically contributing towards resistance of the soil movement, and this particular resistance is taking account in the failure of the soil block, and that's why the system has been stabilized internally, and that's why we are calling it as a internally stabilized soil system. So reinforced earth retaining nailing is the correct answer for the internally stabilized soil system. So here we are basically taking the support for resisting the wall. Here we are taking the dead load of the wall to resist the soil movement, but here we are taking the required international shear forces between the soil and the nails to stabilize the soil. So this is the reinforced earth retaining nailing, and that's why we are calling this particular system as the internally stabilized soil system. So that was question number 4. I guess if you have any doubt, please feel free to ask, as we can move to question number 5. Okay, then this is your question number 5. So the lateral earth pressure coefficient Ka for the active state, Kp for the passive state, and K0 for the rest condition. Then select the correct relationship. So you need to derive the particular relationship between the Ka, Kp, and the K0. So it's not necessary all terms should come into play. Like you can select one of the correct option among all these 4.
Sir,
Yes,
is it a you want correct relationship or a relationship between the three?
correct relationship.
But the question at last line, can you check, sir?
Yeah, I know, but it's not necessary like all the terms
Yeah.
are correlated. Yeah. So just
Okay.
for clarification, I want correct relationship
Okay. Okay.
here. Let's check the answer. I guess it's pretty clear. The answer is D. So let's say K naught is usually the lateral pressure coefficient. Mm, but for the K we know it's related to 1 minus sine phi upon 1 plus sine phi, and then we are having Kp which basically is 1 plus sine phi upon 1 minus sine phi. So for time being, like there's no any particular relationship which can take all these three coefficients into account, but these two, as we can see, are the reciprocal of each other. So K is 1 by Kp, and that's why answer is option D. K is equals to 1 upon Kp. So let's move to question number 6. Again, you need to select the required relation. So retaining wall with a vertical backfill retains a coherently dry backfill at an inclination of I with horizontal. The backfill has an angle of internal friction angle phi, and the coefficient of the passive earth pressure on the wall. So you need to find out the required relation. Question 6C. So let's check the answer. Yeah, answer is option C. So from the earth pressure theories, there's a particular relation. So let's see, if you are having a particular retaining wall, and this retaining wall is supporting a backfill having which is inclined at an angle of I, and the soil available here is having the internal friction angle phi. So whatever coefficient of the earth pressure, so this passive pressure which is acting on the retaining wall, normal to the retaining wall, uh, can be calculated using the lateral earth pressure coefficient of, or the coefficient of the lateral earth pressure coefficient, and that will take the passive forces into account, and this can be given by this particular relation. It's cos I plus root cos I square minus cos phi square, upon cos I minus root over cos I square minus cos phi square. So this is the coefficient of the passive earth pressure which is for the wall. So Kp can be calculated using cos I plus square root of cos I whole square minus cos phi square upon cos I minus square root of cos I whole square minus cos phi whole square. So that is straightforward. If you have any doubt, please feel free to ask. Otherwise, we can move to next question. So here we are having another question. So the correct expression for electrical resistivity of the soil materials. So how can you talk?
Sir, can I check the previous question once?
Yeah,
Is it a cos square pi or cos pi whole square, sir? Every term?
it's same, right?
Okay.
Means whether you can write cos I whole square or cos square.
Okay, okay. Done, sir. Done, sir. Go ahead, sir.
So let's move to question number 7. So you are having the correct. You need to find out what is the correct expression for electrical resistivity of the soil material. So yeah, we are having one answer. Let's check with this. So yeah, answer is option B. It's 2 pi dr. So let's understand this. So usually for measuring the soil resistivity, we basically introduce 4 electrodes into the soil medium, and these 4 electrodes are basically placed at equal distance with each other. So let's say this is D, this is D, and this is D. So in these two particular outer electrodes, we basically introduce current, and in this particular we'll introduce current to this particular electrode such that it is transferred to this, and then we'll measure the potential difference between these two particular electrodes uh, at the time when the current is being induced from this particular electrode to this particular electrode. So the required resistivity to of the soil then is being calculated is 2 times pi, which is basically the resistivity formula which you have learnt in the electrical uh, basic electrical engineering. So it's 2 pi, and then we need to take into account the distance between the electrode, which is d, and r is basically taking account the resistance of the soil. So that's how you will calculate the electrical resistivity of the soil material. So here we are basically inducing the current, and we are basically measuring the potential difference between these two inner electrodes, which is given by rho is equals to 2 into pi dr. So correct answer is B. It's rho equals to 2 pi dr. If you have any doubt, we can discuss this. Okay, so just remember this, like it's a little bit the fundamentals from the electrical side. So just understand at the philosophical level what is basically happening. So you are basically inducing the current from one electrode and it's getting transferred to the another electrode. Meanwhile, due to that there is some potential drop uh, between these two electrodes, and this potential drop will basically help us to analyze the resistivity of the soil, which is given by the 2 pi d into r, where d is the spacing of the electrode and r is basically the resistance of the soil medium. Then we can go to the next question. Yeah, so you are having a retaining wall with a smooth back, and means there is no particular internal shear forces available between the wall and the soil. Then it's having a sand backfill for a depth of 7 meter, and you are also having the water table which is available at 3 meter below the ground, and you are the unit weight of the water is 9.81 kilometer per meter cube. Then let's check the question. So you need to calculate the total active thrust on the retaining wall. So let me check whether question number 7th. Animation. So these are the 4 options. You need to calculate the total active thrust which is acting on the retaining wall. Do we have any answer? It's option C. Let's wait. Okay, so let's check this. So I'll take a new slide. New slide. So yeah, answer is 232, which is correct, given by ARV. Let's check this. So in this particular case, so we are having a retaining wall available here. Sorry. We are having a certain retaining wall. So due to the earth pressure, we'll be having one stress diagram. So this is above the water table and it's having a depth of 3 meter. This is having a depth of 4 meter. So this is the first stress block which we need to make. This particular force is acting for the from the earth pressure from the soil which is available above the water table. So this particular value so will be k into gamma into h, and here it will be h1, and then we are having the another stress block which will be acting on this particular part, but due to the soil medium available above, So this will also have the magnitude, which is k into gamma as 2, and then we'll be having the another stress block which is available from the soil block.
Sir,
Yes.
the rectangle below answer is Ka gamma H1 only, sir.
uh,
It is surcharge effect, no? Whatever you have on the top, it will reflect.
yeah, it's having k into gamma h1. Yeah, okay, that's where the another part will come. So this surcharge will give the required force k, and then we need to take gamma.
Same answer. Ka
Same
gamma H1.
h1. Yeah.
Yeah. Thank you, sir.
Yeah, thank you. And then we are having the another stress block which is available. So this is the k into gamma, and since we are in the water table, so we need to take the submerged unit weight, so we need to reduce the gamma w. And then since the friction angle, I guess it's same for both of them, so above also it's k. Yeah, it's 525 degree and this is 25 degree. Yeah, but this is gamma 1, and here we are having the, okay, so I can take this as gamma 1, and here I can take gamma 2, and then you need to take the h2. And then you are also having the water table available here, so this will provide the required hydrostatic force, and this will have the value of uh, gamma, where should I write, so this will have the value of gamma w into h2. Okay, so these are the particular stresses, like the maximum stresses which will act on the retaining wall from the soil medium as well as the water. So if we can calculate, so let's say the force which is acting due to this, it's your P1. From here it's acting the P2, then you are having the P3, and here you are having the P4. Then the P1 will be half. Okay, first we need to calculate the K1. So K, since the friction angle is same for both the soil, so your coefficient of earth pressure for active case can be calculated using 1 minus sine phi upon 1 plus sine phi. Why active case? Because here we can see the retaining wall is moving away from the soil, so it's 1 minus sine 25 degree upon 1 plus sine 25 degree. So the required value is, it's 0.405. So your P1 force will be half into K gamma 1 H1 into H1 half into 0.405 gamma 1 is how much? It's 17 kilometer per meter cube, and then you are having H1 square, which is 3 square. So answer I'm having is 0.405 into 17 into 9, so that is 30.98 kilonewton. Then from the P2, it's basically again K gamma 1 H1 into H1 square. So okay, it's twice of this basically, so 2 times of 30.98 is 61.97 kilonewton. Then you are having the P3. P3 is basically half of Ka. Ka is your, okay, I'll just write this, Ka gamma 2 minus gamma W into H2 into H2. So that is basically half into your K is 0.405, your K value, and gamma 2 is 22 minus 9.81 into your S2. S2 is how much? 4 into 4. So 0.5 into 0.405 into 22 minus 9.81 into 60. So that will be basically your 39.49 kilonewton. Then another P,
Sir,
yeah,
can you check once P2?
okay, acha, it's H2, sorry, no, but that is H1, okay, it's H2, this one is H2, sorry, thank you. So half into, sorry, it's not half, so
0.405?
0.405 into gamma 1 is
70.
17 into H1 is your 3 and H2 is your 4. Okay, 0.405 into 17 into 3 into 4, so it's basically
82.
82.62
Yeah,
kilonewton.
correct.
Okay, thank you. And then you're having the another hydrostatic pressure from water, so this is half times of gamma W, which is 9.81 into S2. S2 is your 4, and then you need to multiply with the height again, it's 4, so it's 16 into 9.81 divided by 2, it's 78.48. So in the question it has been asked to calculate the total active thrust. So your PA will be basically P1 plus P2 plus P3 plus P4. Your P1 is 30.98, is basically 82.62, your 39.49 is your 78.48. So 30.98 plus 82.62 plus 39.49 plus 78.48. Yeah, so answer I'm getting is 231.57 kilonewton. So it's basically 232 kilonewton. So yeah, correct option is C. It's 232 kilonewton.
Yeah, what is this P4, sir? P4.
This P4 is basically your lateral force which is acting due to the hydrostatic pressure or the water table, since water table is available here, right? So this
Show the
particular,
slides.
oh sorry, is it visible now? Yeah,
Yes.
yeah, so this P4 is basically your, yeah, So this P4 is basically the hydrostatic pressure. So first you are having the lateral earth pressure from the soil medium, then there is another lateral pressure which will be acted by the hydrostatic pressure from the water body. So this water will apply a lateral pressure on the retaining wall. So this P4 has been calculated corresponding to that hydrostatic pressure.
Here, what is the water level? Where it is given, sir, up to?
It's up to 3 meter below the ground.
Okay, okay. Now what is understood?
So that is the part, and now let's move to our next question. So next you
Another
need to
another thing.
calculate the line of action of active earth thrust which is acting on the retaining wall from top. So like basically you need to calculate the resultant, like the resultant position where the total force will be acting on the wall. Yeah, I'll just give you the option. Yeah. Yeah, so we already have answer from ARV before giving the options itself. So let's check with the answers. Yeah. So let's check the answer. So answer is B, option 4. B 4.94. So let's check. So if we see in this particular diagram only, so your P1 basically, since this is a triangular, uh, this stress diagram is having a triangular shape, so we know the lever arm from the top, if we see, is available at 2 by 3. So So the given lever arm can be calculated using its P1, so into Y1 plus P2 into Y2 plus P3 into Y3 plus P4 into Y4. Then basically you are having P1 plus P2 plus P3 plus P4. So this is your Y bar, and let's calculate this. So we know your P1 is acting at 2 by 3 meter, 2 by 3 of uh, four sides, so 2 by 3 into 3, it's basically 2 meter. So 2 into 30.98, then another force is available is P2, and P2 will act as 3 and at the center of the below stratification, which is 3 plus 2. And how much is the force? Is 82.62 into 5 plus P3 is acting at 3 plus 2 by 3 of 4, which is into 39.49. Then you are in P4, so which is basically acting at the same height, which is 3 plus 2 by 3 into 4, and the P4 value is 78.48. And then you have to take sum of all this, so it's 30.98 plus 82.62 plus 39.49 plus 78.48. Okay, so your y bar value will be, let's calculate this. So it's 30.98 into 2, 82.62 into 5 plus 3 plus 2 divided by 3 into 4 into 39.49 plus 3 plus 2 divided by 3 into 4 into 78.48 divided by 30.98 plus 82.62 0.49 plus 78.48. Yeah, so the answer which I'm getting it as 4.938. So yeah, the correct option is B, which is 4.94 meter. So yeah, so the resultant force which is acting on the retaining wall will be at height of, sorry, 3, so it will be acting somewhere here, 4.94 meter. So let's move to the,
This is the line of action line, 4.94.
yeah, line of action.
From top,
Yes, Vijay,
it is from the top or bottom?
it's from the top. So whatever lever arms you have taken for all the respective forces, so the reference line which you have selected for the like partial forces, like, so the individual forces, the lever arm which you have selected, and whatever reference you have selected for those individual forces, the same reference will be given for the whole soil medium for the line of action. So like let's say for the 30.98, so your force was acting somewhere here, so it's P1, right? 30.98, and this was acting, we have taken the reference from here, so it was acting from 2 meter
Third.
from the top. So similarly, whatever y bar value we will get, so we have calculated for the p2, p3, p4, so whatever value we'll get it from the this reference level only. So from the top it's 4.94 meter. Is it fine?
Okay.
Yeah. Then let's move to another question. So okay, any doubt in this? So it was straightforward. So let's move to question number 10. So you are having a non-cohesive backfill which is retained behind an 8.5 meter tall counterfort wall. The void ratio and the internal friction angle are 0.53 and 40 degree in dense condition. The specific gravity of the soil is 2.71 and the gamma W value is 9.81 kN per meter cube. Then the passive earth pressure on the wall is. Yeah, so it's straightforward, like we have done the similar thing in the previous question. The only thing, the challenge here is like to come up with the unit weight of the soil.
So
Yes.
there are two things I need clarity.
Yeah, please.
One is the last question. Is it a passive earth pressure or passive thrust?
It was passive thrust.
Okay, okay. And another one is, do you have any water table anywhere?
In this question number 10?
Yes, sir. Because gamma W you have given unnecessarily. That's why I'm asking.
No, there is no water table.
Okay, sir. Fine then.
Yeah, but you required gamma W. So let's check the answer. The answer is option D. So let's say if you are having a certain retaining wall, it's having a non-cohesive backfill, and it's the counterfort wall, and the void ratio and the internal friction angle. So the E value of the soil available here is 0.53, and the friction angle is 40 degree. The specific gravity of the soil is 2.71, and the unit weight of the water is 9.81 kilonewton per meter cube. So let's say this is the soil medium which is available to you. Then the passive earth pressure PP, we know it can calculate this. So the stress block we are having due to the lateral earth pressure from the soil will have a particular shape. So this earth pressure will act on the retaining wall, and the earth pressure, maximum earth pressure which is available at the bottom, is given by Kp into gamma into H, and this is your H. So the required gamma is not available with us, so we'll use the initial formulas. So your gamma can be calculated. So there is no water table, so we can use the gamma drag. So it's given by G gamma W 1 plus E. Your G value is 2.71 into gamma W into 9.81. It's 1 plus E 1.53. So your answer 2.7, 9.81, answer divided by 1.53. So it's basically 17.38 kilonewton per meter cube. So now your passive earth pressure, which will be there, in the half into Kp gamma H multiply with H. So it's given by half into Kp. Kp, okay, Kp also we need to calculate. So your Kp, or lateral pressure coefficient, for the passive part we know it's given by 1 plus sine phi upon 1 minus sine phi. Okay, so this is they have asked to calculate the passive earth pressure. So this stress block diagram will have a orientation in the reverse shape. So okay, let me correct this. So since the retaining wall is moving towards your soil, okay, again I'm making it wrong.
That's okay, sir. Already what you have drawn is okay earlier.
No, so in that particular case I have drawn for the soil medium moving uh, towards your passive wall. So here I want my retaining wall to move towards the soil. So in that particular case the stresses will act in different direction, right?
Backfill is on the right side, sir. Therefore, it will act on the left side only.
On the left side. So no, so the retaining wall will, okay, soil medium will have the stress diagram like this. So let's say if I am having this retaining wall and this is my soil medium. So if my retaining wall is moving towards the soil, so soil will provide the lateral earth pressure in this direction. Okay, yeah, so then in that particular case,
Previous diagram is okay.
yeah, that was correct. So I think in that previous case I have made mistake. It's because in
No,
the
sir. Only formula will take care of. Pressure diagram will be same. Formula will take up Ka and Kp.
yeah, formula will take care, but I'm trying to understand the free body diagram.
Hmm.
So free body diagram of the soil medium, since the soil pressure, since the wall is moving in that particular direction. Okay, so the KAKP will take that movement of the wall into account, and we don't need to show it into the stress diagram. Okay, half into KP into gamma H. Okay, since this KP and K are basically taking the account of the active and the passive, right? So this free body diagram, if I draw, so if the retaining wall is moving towards the soil, then also you are having the resistance, and if it's moving, then also you are having the stresses acting in the same direction. Okay, yeah, so then we need to stick with the previous diagram. Half into Kp, and yeah, Kp is your 1 plus sine phi, sine 40, 1 minus sine 40. It's basically 4.59. How much Kp value you are getting?
Same, sir. 4.59.
Into gamma 17.38. H square. H is how much? 8.5.
8.5 square.
It's basically 288 1.84 kilonewton, right? So it's closer to option D. Yeah. So answer is option D. So any doubt in this, guys? So it was straightforward. So you just need to calculate the passive earth pressure. If you know the formula, then we can calculate this. Then let's move to over another set of question. It's in different document. Just share that control as. Yeah, so this is related to a geophysical investigation. So in a particular cross-hole test, the trigger and the geophones are 10 meter apart. After impact, the arrival time of SV wave at geophone is 10.5 meter second. The velocity of SV wave is. So you need to calculate the velocity of the SV test in the cross-hole test. let's check the answer. Answer is option D. So let's understand this. So in a cross-hole test, you are having a certain trigger source, and then you are having a geophone.
Sir, pen color is not
Yeah, sorry,
appropriate, sir.
sorry. So you are having a certain trigger source, and then you are having a geophone. This is your trigger, and then this is your geophone. So what do we mean by SV wave? So SV wave is basically the shear wave which is generated due to the strike of this trigger. And why we are saying it's SV, because this shear wave has been polarized, or like it has been oriented in such a manner such that it will only transfer in the vertical plane. So it will go like this, and then it will reach to this particular distance, geophone. Okay, so now here we are talking about the velocity. So velocity, we know it's the shortest distance between the between your trigger and the geophone, which is your D. And velocity can be calculated by displacement upon time. And your time, then you can calculate it using displacement. How much is the displacement? So these are the 10 meter apart, and then you are having a velocity as 10.5 millisecond. So 10.5 into 10 to the power 3. So if we check this value, so yeah, the answer I'm getting it as 952.38 meter per second, which is basically your 952.4. So your correct answer is option D. It's 952.4 meter second. So was it clear? Like it was straightforward. Means you should only know like what is basically happening in that particular geophysical investigation device. Then let's move to question number 14. So this is the vane shear test. So a shear vane of the 75 mm diameter, 125 mm length was placed into soft clay at the bottom of a borehole. 45 Newton meter torque was applied at the failure of the soil occurred. Considering resistance from top and bottom, you need to evaluate what is the undrained shear strength of the clay soil. So you just need to know like how the relation works for calculation of the undrained shear strength uh, in the vane shear test. So some of the question like it's not, I'm not going as per the sequence because I think some of the questions have already covered, so I don't want to repeat that. So just check with the question number. It's question number 14. Yeah, so let's check the answer. Answer is C. So your undrained shear strength value is 34. So usually in vane shear test, you are having a certain prop, and this prop is having further a blade mechanism. When you rotate this particular prop with certain torque, so this particular blade which is embedded in the soil will offer some resistance, and whatever failure which will occur to the soil, so the torque available during that particular part is known as a failure torque. So that torque is related to the undrained shear strength of the soil from a particular relation which is given by Su is equal to T upon pi d square is H by 2 plus D by 6. Here your 75 mm is the diameter and this is the particular length, and then this is the diameter. So in that particular case your torque is 45, your diameter is 75, so it can be written as 0.075 square. Your length of the torque of blade is 125 mm, so it's 0.125 by 2. Your this is the D, so this is 0.075 by 6. So your undrained shear strength value can be calculated as 0.125 divided by 2, answer, plus 0.075 divided by 6, answer, into 3.14 into 0.075 square, 45 divided by answer. So 45 Newton meter.
So 45 we need to convert into kilonewton per meter. Kilonewton meter.
Okay, so the torque we need to
It
take
should
in
be
kilonewton.
45 into 10 power minus 3 numerator.
Newton meter. Okay, it should be in kilonewton meter. Okay, the shear strength in kPa. Okay, so I am getting in the Pascal. Okay, so it's 33970 Pascal, 0.28 Pascal. So in the kPa it will be 33.970 kPa, and that is equivalent to 34 kilopascal. Yeah, so we can go in either manner, like either you can convert this or at the later stage you can convert. So the undrained shear strength value which I'm getting is the 34 kPa, which is the correct answer. So it's straightforward. Once you know the formula and how the vane shear blade works, you can calculate the undrained shear strength value. So this is the one of the widely used uh, geophysical investigation technique, geotechnical investigation technique in our domain. So what's the time now? So it's 7:53. Let's check whether we can take one more question. Okay, we have already covered this type of question. Then retaining wall using that. Okay, we have covered this. We have covered this type of question. Okay, I think we can try this. Yeah. So just have, so last question for today. So okay, is it related to previous question? Okay, then you need to calculate this. So let's have a look on the question number 20. Okay, 17, 18. Okay, it's a different question. Yeah, so question number 19 is there. So you are having the maximum depth of excavation that can be made in a saturated soft clay, which is having a cohesion of 30 kPa and phi equals to 0 degree, and gamma is given to as 20 km per meter cube without any lateral support. So how much deep excavation you can make without providing any lateral support. So that you need to calculate the properties of the soil is given to you. So yeah, we are already having answer. Let's check that. So straightforward, the answer is option C. So your H. So if you are having a certain excavation, so the maximum height of that deep excavation, let's say for the clay soil, is given by H equals to 4C upon gamma root Ka. Your K, so your phi is 0 degree. So cohesion value is 30 kPa. So 4 into 30. Your gamma is 20. So it's 4 into 1.5, which is your 6 meter. So yeah, the correct answer is option C. It's H equals to 4C gamma root Ka. It's again come from the earth pressure theory. So if you apply the equilibrium between the forces which is acting from the earth, like the lateral earth pressure of the soil, and to make the corresponding excavation is stable, if you apply the equilibrium between those two forces, you can get this particular relation which is given by H equals to 4C by gamma root K. And for this particular question, the answer which we are getting is the 6 meter is the required depth of the excavation, which can be made in the saturated soft without any lateral support. So yeah, that's, I think that was the last question for today. If you have any doubt in our today's session, you please feel free to discuss. If you have any other doubt, you can ask that. If not, so we can wind up for today and we can meet next Tuesday at 6 p.m. Okay, okay, guys. So thank you so much. Thank you, ARV. Thank you guys for your patience listening. We'll meet at next Tuesday at 6 p.m. And those who are watching these videos on our YouTube channel, you can post your query on the comment section. Uh, you can ask any of the query related to any of the sample question which we have discussed today. And if you have any other doubt related to any other part of the content, you can post your query in the comment box. Okay, guys. So thank you so much. We can close for today.